Hello everyone and welcome to Redis Days India. And for those that attended our morning technical workshops, welcome back. Having you here, Redis developers, experts, and customers is a great pleasure. India is near and dear to my heart. I had a fantastic time at Redis Days Bangalore last fall, and I'm inspired to see the amount of Redis fueled innovation coming out of India. Our Redis community in India is the fastest growing community in the world, and India continues to be one of our most important international markets. Many of you in the audience don't need an introduction to Redis, but for those of you who do, let's begin asking the question, what problems are we trying to solve here? The answer starts with real-time experiences. You book travel tickets and hotel rooms, and you pay with a credit card. You check your feed on your favorite social media. You're playing an online game. You check your balances in your different accounts on your mobile banking app. In all these daily activities, you expect real-time experiences and use real-time data. Let's put a definition of real-time application experience and real-time data into concrete numbers. There's been a lot of research that eventually boiled down to the fact that 100 milliseconds of end-to-end response time is considered a real-time experience. That's the time where you have little to no delay. This is what I can define as a state of flow between you and the application you interact with. Most of those 100 milliseconds round-trip time is being consumed by the network layer. And that means modern databases need to respond in less than 1 millisecond to deliver true real-time experiences. If an application doesn't provide you with a sub 100 milliseconds round-trip speed, you start to be distracted with other things. It's very likely for you to jump and do something else, and once you do, the likelihood of you not completing that transaction gets higher and higher. So today, if you're a developer and would like to build such a real-time app, let's say on AWS, what would this thing look like? You would need to use a combination of number of different services. You may want Kinesis to collect data, DynamoDB to persist that data, and Elasticache to quickly access frequently used data. And that's not all. You may want something like TimeStream for backend analytics, OpenSearch for searching, and the list can go on and on and on. But these are all different services, and to make them all work together, you end up using a bunch of Lambda functions, a simple queue service, and maybe a few other services. And now you're dealing with a complex system, a system that may also need multiple skill sets to build and many moving parts to manage, which increases both the complexity and the risk. From the very beginning of the project, we've been on a mission to keep it simple. We continue with that mission in mind when we built Redis Enterprise to support mission-critical workloads. With Redis Enterprise, you can use the native features of Redis, such as streams for collecting data, PubSub for distributing the data, lists for queuing, time series and probabilistic data structures for analyzing, JSON for persisting the data, search for indexing, and triggers and functions for advanced event processing. All this in a single system that doesn't need multiple experts to manage. A single system that is blazing fast and keeping it simple. So today, we'll go deeper into key pillars that set Redis Enterprise as the only enterprise-grade Redis that would meet your expectations. First, scale. Redis is now a critical component in so many architectures and needs to support constantly increasing scale. To this end, we've built Redis Enterprise to provide on-demand true linear scalability across any environment, cloud or on-premises. Next, performance. To guarantee these sub-millisecond response times we expect of real-time experiences, you want to be using the most performant version of Redis. And Redis Enterprise is that most performant at scale with the ability to support those sub-millisecond responses at millions of operations per second. And finally, lower total cost of ownership. We know now more than ever organizations are looking to reduce spend and cut costs. Redis Enterprise provides the ability to offload operational costs and reduce the total cost of ownership, hardware efficiencies, and cost of operation with efficiencies built into the design of the platform. Now, let's dive in. I'd like to welcome Tim Hall, our Chief Product Officer, to share the latest innovations across scale, performance, and lowering total cost of ownership for our customers, all while keeping it simple. Tim, welcome.
Welcome to Redis Days. I'm Tim Hall, Chief Product Officer of Redis. For those of you who have been working with Redis, you know that Redis began as an open source project more than 14 years ago. Redis has become the most loved, most used, and most launched database by developers, and this year we were recognized in the Stack Overflow Developer Survey as the most admired NoSQL database. Thank you to everyone who took the time to engage in that survey, and to all of you who continue to engage, provide feedback, and are part of our wonderful community. If you're new to the Redis community, welcome. You might be wondering how we've achieved so much success, and it really comes down to three things: ease of use, performance, and reliability. Redis has been historically known as the best key-value database because its memory-first approach to storing both data and data structures allows you to access that data at unprecedented speeds and scale. It is used for a wide variety of use cases, starting with straightforward caching, but over the years we've expanded on and built an enterprise-grade, real-time data platform that goes well beyond our roots. Today, we're focused on providing enterprise reliability and scalability across a wide range of deployment choices, from fully managed services on the leading cloud service providers to software, either on bare metal or via containers. And we're significantly expanding the core capabilities of Redis itself, allowing it to become a primary database for a wide variety of use cases. Redis Enterprise is a true enterprise-grade platform built from our open source core technology. But we haven't lost sight of our roots, and as Udi mentioned, we despise complexity. We want to provide an easy-to-use and powerful experience for developers, allowing them to solve difficult problems quickly. So let's dive in a little deeper. What we've invested in to create Redis Enterprise fulfills our vision for a comprehensive real-time data platform. First, within Redis Open Source, we have a core set of data structures which allow developers to easily store and retrieve data. We've extended this in the past few years by adding support for JSON data and probabilistic data structures such as Bloom filters, tdigest, and most recently support for vector embeddings. But let me speak for a moment about the brand promise of Redis. Redis allows developers to easily and directly store data and data structures that they are working with. You don't need to transform these into tables and columns and rows like in a traditional relational database. And yes, developers were storing JSON documents in Redis for quite some time, but they were converting it into strings, and that conversion needed to take place every time they wanted to work with that JSON document. But that simply didn't meet the brand promise of Redis. And so we invested in native support for JSON to eliminate this complexity and fulfill our brand promise. And we continue to invest heavily into developer experience. What does that mean? We want to make it easy for developers to build applications which can take advantage of all the capabilities of Redis. This means offering supported client libraries in specific languages that developers are building apps in. It means offering a companion desktop application that developers can use to help interact with Redis and see how their applications are working. But we're also extending the capabilities of Redis even further. Specifically, we have introduced event streaming capabilities where you can interact with data via stream. And as part of Redis Enterprise, we're utilizing that capability to introduce advanced data integration options, such as leveraging change data capture from other data platforms to ingest data into Redis. We've also introduced a query and search capability to allow you to inspect hashes and JSON data within Redis. You can define secondary indices, which allow you to move beyond their traditional key-value data access experience. I mentioned vector embeddings before. You hear a bit more about how Redis can be used in the world of generative AI and vector similarity search in another session at Redis Days. So if working with use cases leveraging machine learning, online feature store, or building solutions leveraging generative AI is of interest, don't miss that session. We've also introduced server-side functions to interact with data within Redis in a variety of ways, and I'll talk a bit more about this later. Lastly, To fulfill requirements of organizations everywhere, we've invested deeply to ensure enterprise-grade capabilities exist well beyond what Redis open source is capable of. Specifically, Redis Enterprise supports maintaining speed at millions of operations per second, high durability as it's built to withstand failure, global applications with low latency and reads and writes via active-active geodistribution, and it's also cost-effective, delivering support for multi-tenancy and data tiering between RAM and flash. And it's highly secure, including auditing capabilities to support integration with security information and event management tools. Redis Enterprise takes the strong core of Redis and adds on a full set of features that are required to deploy mission-critical, real-time applications at scale. And of course, it's supported by the world's foremost Redis experts here at the home of Redis. If you've attended our most recent Redis Days virtual event, or if you're actively keeping up with our blog, you've probably heard that we're working on the latest release of Redis, Redis 7.2. And we are very close to sharing all of the details and advancements we made. But I thought I'd dive into some of the highlights you can look forward to, starting with what developers can expect. First, if you haven't heard of Redis Insight, it's the best GUI for developers working with Redis. We originally launched Redis Insight in 2019, and we've seen so many of you find great success with this new tool. We've recently published it on both the Apple App Store and the Windows App Store, and it can also be downloaded from FlatHub and Snapcraft. Redis Insight helps increase your productivity by allowing visual browsing and interaction of Redis data. You can look at keys, add keys, delete keys, group data, display data in pretty print, hexadecimal, and any other number of data formats. Way easier to develop when you can see your data. It provides a native CLI within the editor with syntax highlighting, and it has log analysis, tracing, and debugging. It's everything you want while developing with Redis. The latest release just arrived and now allows you to easily connect Insight to your Redis Cloud account if you are using the fixed tier. In addition, we delivered a number of user experience improvements for those of you that are using full text search or executing queries. And there are other improvements for filtering and bulk actions as well. If you haven't experienced the power of Redis Insight, I highly encourage you to go check it out. Now I'm going to dive into two other areas with important advancements that are part of Redis 7.2. The first is our support for language-specific client libraries, and the other is a new capability called triggers and functions. First, let's talk about client libraries. As such a popular open source technology, we're very lucky to have an amazing community that has made it possible to build applications with Redis in almost any language. If I look today, I think we have over 100 community-created client libraries, and it's a great luxury to have multiple libraries per language to choose from, depending on what you're building and your programming style. However, for new users just starting out, or for experienced developers looking for a consistent experience across languages, including the performance features, capabilities, and security, this actually isn't great. Which library is best for me? How can I tell? And so what we've done is to engage more deeply and directly with 6 of the main libraries across the most commonly used programming languages to drive that consistency. We're leaning into contributing and supporting the advancements of these specific projects. Our goals are to improve the developer ergonomics of building applications with these libraries, ensuring greater consistency in the terms of access to the features and functions available from Redis in lockstep as we continue to advance the capabilities of the platform, and to expand upon the documentation with specific examples for how to use each of these libraries. As a part of Redis 7.2, across our open source, source available, and commercial offerings, we are providing support for RESP 3. This is a long overdue protocol upgrade that we are going to continue to invest in and advance going forward. And speaking of lockstep, updates to these clients will be made available to support RESP 3 as part of the 7.2 general availability, and for those community members building their own clients, RESP 3 will dramatically simplify the development and maintenance process. Now let's talk about programmability and what we're delivering with triggers and functions as part of Redis 7.2. We're introducing JavaScript as the primary language for authoring functions, and we are providing a number of mechanisms to trigger those functions, including direct command-based invocation or via a key space event. But let's take a closer look. Redis has had support for server-side processing using scripts written in Lua for quite some time. This provided developers with an easy way to execute application logic on the server by writing Lua scripts passed to Redis over the wire. This is a great choice for implementing simple logic like conditional updates across multiple keys or combining different data types. However, we've had lots of feedback about challenges with our initial approach. First, network calls can get large by having to repeatedly pass the scripts over the wire. Second, even with local caching of scripts, scripting can quickly become complex to manage when you have to maintain consistency of scripts across hundreds of clients. And due to their localized context, this approach has the potential to limit sharing and code reuse, practices we generally like to encourage. So in Redis 7, we introduced functions as an evolution of scripting, providing first-class support for server-side programmability. Whereas ephemeral scripts are considered part of an application's domain, functions extend the database server itself. Functions can be used to expose a richer API composed of core Redis commands developed once, loaded at startup, and used repeatedly by various applications and clients. Because functions are part of the database and therefore declared before use, applications aren't required to load them during runtime. Redis manages functions as an integral part of the database and ensures their availability via persistence and replication. This is a great step forward for making developers' lives easier and extending the power of Redis itself. But we think there's still more we can do, and there were a number of things developers have wanted to do programmatically which were either challenging or impossible to do. As we listened to feedback, we took a step back to assess the challenges developers faced with an eye towards eliminating complexity. We reviewed the inputs and requirements being shared with us. The need to expand programmability on the server side to better handle data events, including streaming data, was clear. And while we did a significantly better job addressing the maintenance challenges with functions in Redis 7, one of the biggest challenges was to address programmability at scale. Less than 4% of professional developers know Lua, and as a result, these programmability features are simply out of reach. There were additional operational requirements which emerged as well, including better support for clustered databases and ensuring better consistency across the open source and commercial editions of Redis. All of this led us to triggers and functions. As a preview in the Redis 7.2 release, we attempt to take these inputs and requirements and produce something that is both simple and powerful. JavaScript is the implementation language, wildly popular and simple. Triggers are used to invoke these functions, and we've expanded support for the breadth of Redis capabilities, including streaming. In addition, there's first-class support for clustering while maintaining the easy-to-load and maintenance mechanisms introduced as a part of Redis 7. The introduction of triggers and functions makes Redis more useful. It allows Redis to become a powerful engine for event-driven data processing while allowing developers to write and run their functions on data stored within Redis. Here you see the specific triggers that we're introducing, including on-demand commands, event-driven, and stream processing. We're also looking to introduce a timed trigger function in the future. Let's take a deeper look at a specific example. A common use case where Redis is used is to build API rate limiting. Essentially, each user token is allowed a certain number of requests in a limited amount of time. To solve this problem, you can use a simple fixed window counter algorithm which checks the number of calls in a specific time interval. Implementing this algorithm with Redis is straightforward and is based on counters. The traditional logic of a rate limiter implies that the API gateway checks the current calls in a specific minute. In this example, the counter keeps track of the number of requests per token in the current minute. If the counter is under a threshold, we increase it and allow the request from the client. Otherwise, we deny the operation until the next minute, when we'll restart the count with a new counter. With the introduction of triggers and functions, we can enhance the data associated with each token without any impact to the rate limiter itself. Say we want to capture the time of the last API call. We can now extend the basic rate limiter by attaching a key space trigger that executes a Java function whenever the counter is incremented. When the counter is incremented, we store the last updated timestamp in a hash co-located in the same shard as the counter itself using a hashtag. Of course, additional information can also be stored in the hash, such as the total number of requests for that token. So you might ask, so what? That seems like a simple change I could make on the rate limiter itself. What can you really do with this kind of data enrichment? Since Redis provides support for query and search capabilities, and data in hashes can be indexed, you could then query the user metadata to provide useful information, such as the oldest and newest token usage, sorting by tokens by usage, sorting tokens by the total number of requests, and more. Additionally, because Redis also provides support for time series data, storing all the requests in a per token time series, you can easily enable token usage analytics, usage during a time window, averages, and more. Hopefully, these relatively simple examples provide you with a tiny glimpse into what's possible with triggers and functions and how you can easily take advantage of Redis in some new and unique ways. We're excited to put this into the hands of developers everywhere and see what you can create. So where can you get your hands on triggers and functions and explore this rate limiting example? Here are a couple pointers where you can dive in a bit deeper. We've packaged up the rate limiter example for you in GitHub. And if you want to do some exploration of your own, you can download Redis Stack, the latest 7.2 release candidate, or the Docker image, which includes triggers and functions preview. There's no need to wait. It's available for you right now. If you're into cloud, we'll have this available in our free and fixed tier, starting with AWS Singapore and GCP Tokyo very soon. And if you want to explore the preview as part of the flexible tier in Redis Cloud, we've got 20 spots available for folks to come and engage with us to provide feedback and help shape this further. Reach out to us and we'll get you hooked up. And lastly, for our enterprise software customers, triggers and functions will be a preview as part of Redis Enterprise 7.2. We are continuing our commitment to fulfill the original manifesto of Redis by abhorring complexity. And we're deeply investing to continue to improve the developer experience overall as we continue to advance on the features and capabilities of Redis itself, whether that's via Redis Insight, deeper support for client libraries, or with triggers and functions. Now we're going to take a look at a new set of capabilities that we're introducing as part of Redis 7.2. Redis is often used in conjunction with many other databases. What we've heard is that many of you, whether you're developers or architects, would like to make the movement of data between Redis and these other platforms easier. So to simplify the most common use cases, we're introducing a set of capabilities to Redis Enterprise called Redis Data Integration. We are starting with a software-based solution, and it's open and extensible to allow for third-party integration. Redis Data Integration as a part of Redis Enterprise is intended to simplify 4 specific use cases. The first is prefetch, where Redis is following changes to the database in near real time. The objective is to keep writing data to the database, but speed all queries by offloading them to Redis. This is achieved by leveraging the underlying change data capture mechanisms of the source database and delivering a configuration-driven denormalization of data. Common scenarios for this approach are performance and scale acceleration for mobile applications, application modernization, such as providing data access for many microservices, or real-time inventory for online shopping, prefetching data from branch databases or other legacy inventory databases. The next use case is right behind. Data is written to Redis, and the goal is to achieve fast eventual consistency in the underlying database. Why is this important? It allows applications to speed up both reads and writes using Redis while automatically updating other systems of record. In this case, Redis triggers are used asynchronously to drive codeless normalization of data and writes to the underlying database. This approach allows you to cope with a high-scale, mixed workload use cases, replacing streams or queues. It also might be leveraged in fast processing of financial transactions, such as fast write and fast reads for immediate actions like fraud detection. Next is read-through, which automatically fetches data from the underlying database to Redis if it is not already present. The goal here is to simplify the application development, as the developer doesn't have to know anything about the underlying data store at all. And finally, write-through, where data is updated in Redis and the underlying database in a single write, keeping them consistent. Now, we've just released the prefetch functionality as a public preview. The documentation describing this, along with the write behind and read through use cases, which are both in private preview, are up on our documentation site for you to explore. Write through is on our roadmap for delivery next year. So let's take a look at a use case from one of our customers who's been a key design partner as we've been developing Redis Data Integration. This customer was looking to boost performance of their mobile banking application. The underlying database is Oracle, and they were having some trouble achieving both a low latency for the mobile banking app while dealing with the volume of users, without paying a fortune to Oracle. By leveraging Redis Enterprise and our data integration capabilities to prefetch the data, this customer was able to dramatically lower the latency while also eliminating crashes and outages associated with peak volumes. Redis Enterprise also provided a simple and cost-effective way for them to scale up when necessary. Again, this use case was delivered via configuration and not code. If I've gotten your attention with this use case, you probably want to know what sources we can prefetch data from. So take a look here. These are the currently supported data sources, and we're continuing to work to advance support for additional sources all the time. Archion has leveraged the open API we provided so that their solution can plug right into the Redis data integration prefetch use case. If you're an existing Archion customer, you should be able to leverage any of their existing data sources with Redis as a result. And we're working to expand our integration partners based on this early success. Okay, finally, let's take a deeper look at what's coming from a simplification and total cost of ownership perspective for those of you who operate Redis. Let's talk for a minute about the volume of data we're all working with today. It continues to grow at a phenomenal rate. Because Redis is an in-memory database and RAM is the most expensive way to store data, this can create some challenges. We've talked with many of our enterprise customers about how mission-critical Redis is to their businesses, but that as data volumes grow, the cost of continuing to run Redis at scale is larger than they would like. In some cases, this causes a significant rethink of application architectures, and that is time that could be spent on new problems instead of addressing ones you thought you already solved. Redis Enterprise introduced a solution to this problem. Now, it can't be used as a silver bullet for every use case, which we'll explore more in a minute, but it can deliver a significant cost savings in a number of very common scenarios. The solution is to store the most frequently used data in RAM and let the warm data reside on cheaper, high-performance storage. There is a performance and cost trade-off being made here, but the benefits can be significant. Now, you might have heard about this already. We previously called this Redis on Flash, but we're renaming this to auto-tiering with the release of Redis Enterprise 7.2. The idea behind auto-tiering is to deliver a single operational experience at a lower total cost of ownership and without impacting your existing application. Okay, so I'm sure that sounds great, but like I said, unfortunately it can't be used for every scenario today. So specifically, what use cases are a good fit for auto-tiering? When a subset of the entire dataset is the working set or the hot data, an example of this includes time-based data like in mobile banking or fraud detection where insights are generated from real-time data. But where it is not a fit are in places where the application is highly latency sensitive. Again, there's this performance trade-off between the tiers. Also, in cases where the size of the key and the size of the associated value are roughly the same, or worse, in cases where the size of the key are significantly larger than the associated values. Why? The entire data index is still stored within RAM. Also, if you're looking to leverage Redis Enterprise's active-active feature or the search and query feature, it's worth a conversation with your Redis sales rep to understand the limitations of each of these features when combined with auto-tiering. Okay, so maybe you were already aware of auto-tiering under the old name. So what's new here? What we're delivering in addition to the name change with Redis Enterprise 7.2, both in software and in cloud, is that we're doubling the performance. So for the same cost, you get 2 times the throughput. This certainly expands the applicability of auto-tiering when it comes to high throughput use cases, and we are super excited to deliver this more performant and cost-effective approach for working with large volumes of data and Redis. And we won't stop there. We're looking to continue to invest in auto-tiering beyond Redis Enterprise 7.2, and we're eager to work with many of you to understand how Redis can continue to deliver a lower total cost of ownership in a way that meets your latency, performance, and throughput goals. Finally, I want to share a significant refresh that we've made to the Redis Enterprise Cluster Manager user interface that will arrive with Redis Enterprise 7.2. Let me take you on a brief tour of the new experience. We spent the last year working with dozens of our customers not only to improve the look and feel of the Cluster Manager UI, but also to simplify the workflow of the most common tasks that operators perform. We've revisited the organic sprawl of feature additions which crept into the product over time and reorganized them into easy-to-understand categories. The design is simple and straightforward. The most critical pieces of information are easy to find, and more detailed information is only a single click away in almost all cases. We've also highlighted recommendations for various settings and added more context to help operators understand what they're looking at. We are eager to put this in your hands and are thankful for everyone who participated in this redesign of this critical part of Redis Enterprise. Of course, now that we've reset the foundation for the cluster manager, we've got more that we will layer into it, so stay tuned. Okay, so I hope you enjoyed this sneak preview of what's coming in Redis 7.2. There's actually much more to explore, but I'll wrap up with just a few final thoughts. If you've started with Redis open source, we hope you've had a joyful experience, and we hope that you've seen how simple it is to get started and how powerful you can be by using Redis. If you started with Redis Enterprise Cloud, we hope you've seen how easy it was to get started and have a fully managed service up and running. As you continue to grow and scale, Redis Enterprise remains the most cost-effective way to achieve that. The multi-tenant approach allows you to pack more workloads onto the same hardware, and this is true whether you want to continue on a self-managed experience via software or whether you sign up for a fully managed service in the cloud. Now, due to the popularity of Redis, we know there are other options out there who claim to be based on Redis open source or are Redis API compatible. These come from folks who simply deploy, manage, and run Redis open source to API compatible offerings which are based on Redis open source, but are most certainly have been forked and altered in ways which may not behave like your application expects from Redis. So don't be fooled by cheap knockoffs or managed solutions that don't deliver additional value beyond our open source offering, or have attempted to replicate what we've built since the early days of Redis. The clear path to success with Redis is with Redis Enterprise, whether it's via Redis's own cloud offering that provides you everything you need in an enterprise-grade solution while maintaining the simplicity you love, or software. We can support whatever path you choose. We are the most cost-effective way to achieve your goals. Of course, not to be overlooked is that Redis Enterprise is supported and managed by our team of dedicated experts with thousands of deployments and millions of hours of operational expertise. We are the experts, and you will sleep better at night knowing you have the most knowledgeable and skilled team behind you. I'm going to leave you with a QR code and some links. There are so many resources available for you to learn more and assist you on your journey with Redis. And with that, thank you so much and enjoy the rest of Redis Days.